My dear students, today I am going to discuss coordinate geometry for class 10, the whole chapter. This is the third video in the series. So already I made two videos. In those videos I discussed the distance formula, its derivation and application. So today I am going to show you some more application of the distance formula. All right. Now this is the first question. So these 4 points are given. So point A 4, 2. Point B -3, 2. Point C -3, -1. And point D 4, -1. So 4, 2, -3, 2, -3, -1 and 4, -1. Now these 4 points are given. So you are asked to show that they are vertices of a rectangle. So the question is this: show that these 4 points A, B, C, D are vertices of a rectangle. Now, in order to show that a quadrilateral is a rectangle, what you have to show? You have to show that opposite sides are equal and diagonals are equal. So to show that a quadrilateral is a rectangle, you have to show opposite sides are equal and diagonals are equal. Now let us find out all the 6 sides, 4 sides and 2 diagonals. Now first of all, AB. Now using the distance formula you can find. So let us do it quickly because already you are well acquainted with that formula. All right. Now AB is, it will be what? 7 square, 4 plus 3, 7 square plus 2 minus 2, 0. That means 7 square 49, so 7 units. So AB is 7 units. Then BC. So BC is what? -3 cancel, 2 plus 1, 3, 9. That means 3 units. 3 units, all right. Then CD. So CD equal to root over CD -3 -4, that is 7, 49, 49. So this is 9 plus 0, this is 49 plus 0. So that means square root of 49, 7. All right. Then DA. So what will be DA? DA. So cancel 3, 9. Square root of 9. 9 plus square root of 9 plus 0. So 2 is 0. So that will be what? 3. All right. So 3 units, 3 units, 7 units, 3 units. Then AC. AC. So what will be AC? AC. AC will be 4, 7 square. 7 square 49. So this and this 7 square 49 plus 9. That means root 58. Root 58. All right. And then BD. BD. BD equal to what? BD. BD will be then 7 square 49 plus 49 plus 9. That means square root of 58. So all the 6, 1, 2, 3, 4, 5, 6, 6. So 4 sides and 2 diagonals we have found out. All right. Now you see opposite sides, 3, 3. So these two are equal. So this will be, let me draw it a little bigger. So this will be 3, this will be 3. You see these two sides, BC and DA. BC and DA. So AB is 7. So A, B, C, D. Yeah, that is a quadrilateral. AB is 7. So this is 7, BC is 3, then CD is 7. This is 7, then DA is 3. Then diagonals, yes, AC is root 58. So this is root 58. square root of 58, and this also square root of 58. Okay. So that is the picture. You see, opposite sides are equal. So AD equal to BC. So AD equal to BC. You see, 3 3. Then AB equal to CD. AB equal to CD. AB equal to CD, 7 and 7. Then AC and BD are diagonals. AC and BD are diagonals. You see, they are equal 58 root 58. So we have shown in the quadrilateral opposite sides are equal and diagonals are equal. Therefore, we can conclude what? It is a rectangle. So, since opposite sides are equal, and also what? Diagonals are equal. Diagonals are equal. So we have shown opposite sides are equal. Opposite sides are equal and also diagonals are equal. So therefore, what we conclude? Since this, therefore, what we conclude? ABCD is what? Rectangle. ABCD is a rectangle. So we are asked to show these 4 points are vertices of a rectangle. So that is the conclusion. So they must be vertices of a rectangle. Which rectangle? ABCD. Is it clear? Okay, so this was the first example. Now come to the second example. In the second example, we are asked to show parallelogram. Now square we did last time. So today rectangle, then next will be parallelogram. Now to show a quadrilateral parallelogram, what you have to show? Opposite sides are equal. Opposite sides are equal, and if possible also diagonals are not equal. If opposite sides are equal and diagonals are equal, it is a rectangle. But if only opposite sides are equal, then it is a parallelogram. Okay. Now this is the next question. So again, these 4 points are given. A is given 0 0. So this is the origin. Then B is given 2 5. Then C is given 6 5. 6 5, and D is given 4 0. So these are the 4 points given: 0 0, 2 5, 6 5 and 4 0. Now you have to show that these are the vertices of a parallelogram. So you have to show these are the vertices of a parallelogram. Okay. Again, like before, we must find all the 6 sides. All right. So let us find out, like before, all the 6 sides using what? Using the distance formula. Okay. So let us see AB. So what will be AB? A will be 2 square 4 plus 5 square 25. That means root 29. Root 29 units. All right, AB. Then BC. So what will be BC? BC will be, say, 4 square 16 plus 16 plus 0. That means 4 units. All right. Then CD. So what will be CD? CD will be 6 minus 4, 2 square 4. CD, AB, BC, CD. Then CD is what? 6 minus 4, 2. 2 square 4 plus 5 square 25. 25, that means root 29. Root 29. Root 29, and then DA. DA. DA will be what? 4, that is 16. 16 plus 0, that means 4. Yes, actually we got the opposite sides equal. All right. Now the two diagonals AC. So what is AC? AC, that is 6 square plus 5 square. 5 square, that means root over 6 square is 36. 36 plus 6 square 36. So AC will be root 61. 36 and 25, 61. Root 61, isn't it? 36 plus 25, 61. And then BD. BD equal to square root of what? BD. BD 4 minus 2 to 4. 4 plus 25. 25, that means root 29. Okay. Now, yeah, so you see, okay, now AB is root, these two equal, you see, root 29, root 29. So this will be root 29, this will be root 29. So AB and CD. So this is AB and CD. As you see, AB is root 29, CD is root 29. So AB equal to CD. AB equal to CD. All right. Then BC and DA, 4. So BC is 4, DA is 4. Yes. So BC is 4, then DA is 4. BC and DA 4, 4. All right. So we have shown the opposite sides are equal. Actually, it should be enough to show that it is a parallelogram, because what is the definition of a parallelogram? A parallelogram is a quadrilateral in which opposite sides are parallel, or you can say a parallelogram is a quadrilateral in which opposite sides are equal. So those are the important theorems. So we have proved opposite sides are equal, so we can safely say it is a parallelogram. But if you want to be more than 100% sure, then you also show that the diagonals are not equal. Now diagonals are these two, BD and AC. These are the two diagonals. You see they are not equal. So root 61, this longer one is root 61. So BD is BD. BD is longer one is root 61. So therefore this will be B. This will be B, this will be D. All right. So AB and CD, root 29, root 29. AB and CD. Oh, actually this will be so this root 29, this is 4, this is 4. Then BD root 6, AC, what is AC? Root 60, AC root 61, and BD root 29. BD root 29, AC root 61. Okay, let me show this one. So BD is BD is root 60, AC is root 61. So this is root 61 AC. So this is A, this is C, this is B, this is D. All right. Yes. So AC is root 61. This longer one is root 61, and the shorter one BD is root 29. So this is root 29. Then AB root 29, AB root 29, CD root 29. So this is root 29, this is root 29, this is 4, this is 4. Okay. So AD equal to 4, BC equal to 4, then CD root 20. Yes. So you see, we have shown opposite sides equal and diagonals are not equal. So as I told you, it should be enough to show that opposite sides are equal, then you can call it a parallelogram. But to be more than sure, what you show that also diagonals are not equal, because if diagonals happen to be equal, then it is a rectangle. All right. So since opposite sides are equal, and diagonals are not equal, therefore ABCD is a parallelogram. So since opposite sides are equal and diagonals are not equal, therefore ABCD is a parallelogram. So we were asked to show these 4 are vertices of parallelogram. So we have done it. So our conclusion is these 4 points are vertices of a parallelogram, and that is a parallelogram. So in the exam, when you show the solution, also show the diagram. Okay. All right. So this was the second one. Okay. Then we go to the third question for today. Third question of today. All right. Now here, now we have to show rhombus. We have to show the 4 points are vertices of a rhombus. So which are the 4 points? So these are the 4 points given. A equal to 0, 3, A equal to 0, 3, then B equal to 5, 0, B equal to 5, 0, then C equal to 0 minus 3, 0 minus 3, and D equal to minus 5, 0, minus 5, 0. So these 4 points are given. You have to show that they are the vertices of a rhombus. They are the vertices of a rhombus. So which are the points? 0, 3, 5, 0, 0, minus 3, and minus 5, 0. Now what is a rhombus? A rhombus is a quadrilateral in which all sides equal. All sides equal. So this is a rhombus. You see, all sides equal. All sides equal. Suppose A, B, C, D. All sides equal, but diagonals are not equal. If all sides equal and also diagonals are equal, that will be a square, which we did in the first video, I think. If all sides equal and diagonals are also equal, then it is a square. But if all sides equal here and diagonals are not equal, then it will be a rhombus. So that is what we are going to show. Again, you have to find all the 6 sides, all the 6 straight lines. All right. So AB equal to what? AB equal to 5 square, 25 plus 9, that means root 34. Root 34. All right. Then BC, what is BC? BC is again 5 square, 25, 25 plus 9, that is root 34. All right. Then CD, what is CD? CD 5 square, 25, again 25 plus 9, that is root 34. All right. Then DA, what is DA? DA again 25 plus 9, 25 plus 9 equal to root 34. So I am doing first because already you are acquainted with that distance formula, how to use it. Okay. Then we have to find the 2 diagonals. Which are the diagonals? Diagonals are going to be AC and BD. Now what is AC? AC will be 0, 3 plus 6 square. 6 square, that is 6. AC 0, 0, then 3 minus 3, 6, 6 square. So root over 6 square, that is 6. Okay. Then BD. What is BD? BD will be 5, 5, 10, 10 square, 10 square. So 10 square plus 0, that is 10. Right? Okay. So see, all the 4 sides are equal. AB, BC, CD. So root 34, root 34, root 34, root 34. This also root 34. And these are the 2 diagonals. Okay. The longer one is 10. This is 10. This one is 10. And the shorter one is 6. This one is 6. So all the four sides are equal and diagonals are not equal. This is 10, this is 6. So it is a rhombus. You followed? So since all sides equal, since all sides are equal but diagonals are not equal. But diagonals are not equal. Since all sides are equal but diagonals are not equal, therefore what? Therefore ABCD is rhombus. ABCD is rhombus. So we have shown all the four sides are equal. Which four sides? AB equal to BC equal to CD equal to DA. All these four sides are equal, but these two diagonals are not equal. Therefore, it is a rhombus. So our conclusion is these 4 points are vertices of a rhombus, and that was what we were asked to show. Show that these 4 points are vertices of a rhombus. Okay. All right. Next. Now you are given 4 points in the next problem, and you are asked to show whether they form a quadrilateral. So there are 4 points here. You see, these are the points. A equal to -1, -4. Then B equal to 0, 3. B equal to 0, 3. Right? Then C equal to 3, 1. C equal to 3, 1. And then D equal to -3, 5. -3, 5. So the 4 points are given: -1, -4, 0, 3, 3, 1, and -3, -3, 5. And the question is, check, verify whether these 4 points are vertices of a quadrilateral, whether they form a quadrilateral. That is the question. All right. So 4 points are given. You have to check whether they are vertices of a quadrilateral. That means whether they form a quadrilateral. Now, this is the way. If suppose there are 3 points, 3 points out of these 4 points, 3 points are collinear. Suppose out of these 4 points, 3 points are collinear, 1 point is not collinear. 3 points are collinear, but 1 is not. Then it is not a, then they cannot form a quadrilateral. Then they will form a triangle only. But if no 3 points are collinear, then it will be a quadrilateral. So we have to check now whether any 3 points are collinear. For that purpose, we have to find now how to show 3 points collinear, that we discussed before in the previous video. All right. So we have to find all the 4 sides. So AB equal to square root of what? AB is square root of what? 1 square 1 plus 7 square. That means 50. So root over 50. Root over 50. All right. 49. There's a -1 of square 1. So okay, then BC. Then BC. So BC is what? Root over, so 3 square 9 plus 2 square 4, that is root 13. All right. Then CD. What is CD? CD will be 3 6 square plus 4 square. That means 36 plus 16. 36 plus 16 will be root 52. 36 plus 16 will be root 52. All right. Then DA. AB, BC, CD, then DA. What is DA? DA is 3, 1, 2, 4, then plus 9, 4 plus 9, 81. So 4 plus 81, that means root over 85. Root over 85. All right. Then AC. AC. If 4 points are given, you have always to find six lines: A, B, B, C, C, D, D, A, and then AC. AC will be root over 4 square, that is 16, plus root over 4, 16, 16, 16, 25. 25, that means 41. Okay, finally BD. So what is BD? BD will be 9 plus 9, 9 plus 9, that is 18, root over 41, then root over 18. BD is 9 plus BD is 9, then 5 minus 3, oh, this is 4. 9 plus 4 will be 13 only. 9 plus 4, 9 plus 4, 13. All right, so 50, then root 13, 52, 85, 41, and this. Okay. All right, now let us see. This is root 13, this one, BC. BC is root 13, then BD is root 13, and this one, CD. CD is what? 2 root 13. You can express it as a mixture. This is 4 into 13. So square to 4, yes. Now you see, yes, let us take this one, this, and this. So you see, BC plus BD is CD. This plus this, root 13 plus root 13 is 2 root 13. This one, it's like x plus x twice x. So root 13 plus root 13, that 2 root 13. So this plus this equal to this. That means root 13 plus root 13 equal to 2 root 13. Isn't it? Now root 13 means BC. BC plus this root 13 is BD. BC plus BD equal to 2 root 13. 2 root 13 is which one? CD. Yes, you see. So sum of two sides equal to another side. Therefore, these 3 points are collinear. Which 3 points are collinear? BCD. BCD are collinear. So this is a straight line CD. CD and B is here. This is B. So BC plus BD, BC plus BD equal to CD. That means CBD, these 3 points are collinear. These 3 points are collinear. B, C, D. So B, C, D, B, C, D, these 3 points are collinear. So all this we discussed in the previous video, how to do it, okay? Now see, these 3 points are collinear. Now only one point is collinear. A is not collinear. So A is somewhere here. A is somewhere here. So 3 points are collinear and A is not collinear. Now it will form a triangle. It cannot form a quadrilateral. So that is our conclusion. So these 4 points cannot be vertices of a quadrilateral. All right. So since CBD are collinear, so that is what you are going to write. Okay. So what we will write? Since CBD are collinear, since C, B and D, CBD are collinear, hence the 4 points A, B, C and D are not vertices, are not vertices of a quadrilateral. So since these 3 points are collinear, only one is not collinear. Therefore, all the 4 points, therefore the 4 points A, B, C, D cannot form a quadrilateral. That means are not the vertices of a quadrilateral. Are not the vertices of a quadrilateral. So that is the conclusion. So not. All right. Okay. So this is the thing. Then another for today, the last one for today. So we have discussed square, rectangle, parallelogram, rhombus, quadrilateral, all right. All these different types of quadrilateral we have discussed. Okay. Now this is a slightly different type of question. If P is equidistant from, this is the question, you see I am writing the question here. If P, the Pxy, if P is equidistant if P is equidistant from the point A is 7, 1, and another point B 3, 5, B 3, 5. So this is the question. If this point is equidistant from these 2 points A and B, then find a relation between x and y, So this is a question. This point P xy is equidistant. Equidistant means at equal distance from these 2 points. So you have to find the relation between x and y. That means you have to find an equation containing x and y. You have to find an equation containing x and y. All right. Now P is equidistant from A and B. Now see, this is the point P. It is equidistant from A. This is A. It is equidistant from B. That means these 2 sides are equal. P is equidistant from A and B. That means P is at equal distance from A and B. That means PA equal to PB. So that is what is given. PA equal to PB. This is given. P is equidistant from A and B. That means PA equal to PB. This is given. And this is the picture. This is the diagram. All right. So now you have to find an equation containing x and y. All right. Okay, let us see now. So obviously, I think you have understood that using distance formula, we have to find PA and PB, isn't it? So you have to find PA and PB. So PA equal to what? Yes, PA. Now this is P, this is A. So what will be PA? Root over x minus 7 square plus y minus 1 square. This is PA. And what will be PB? So PB equal to what? PB equal to now P is xy, and B is 3, 5. B is 3, 5. P is xy, B is 3, 5. That means x minus 3 square plus y minus 5 square. Okay, so x minus 3 square, y minus 5 square, and x minus 7 square. Okay, so since it is given P is equidistant from A and B. So since P is equidistant from A and B, so therefore PA equal to PB. So therefore what we get? PA equal to PB. That means this equal to this. So this root over, that is this root over equal to this root over. Now this root over we must expand A minus B whole square formula. That is x square plus 7 square 49 plus 14x. This is square. This is PA square. This is a PA square plus y minus 1 whole square. That means y square plus 1 minus 2y. Y square plus 1 minus 2y. So this is PA. PA equal to root over this square plus this square. All right. So this square we must use A minus B whole square. So that is equal to what? That is equal to square root of this is PA equal to PB. This is PA and equal to PB. So what is PB? this one, square root of this will be x square plus 9 minus 6x, then plus y square plus 25, y square plus 25 minus 10y. All right. So since P is equidistant from A and B, therefore PA equal to PB. PA equal to PB. So this is the diagram as I showed you. So these two are equal. So this is P, this is A, this is B. So PA equal to PB. Now PA is this one. So we have expanded. PB is this one. We have expanded. They are equal. Okay, they are equal. Now only thing simplify. Now only question is simplifying. So this gives equal to. Now this root we can cancel from both sides. Squaring both sides, the root will go. So then what will remain? X squared is, yes, so see if a square will go, then what will remain? X square. So x square cancel from both sides. Y square cancel from both sides. Just equation rule. First of all, the square will go away. Then x square from both sides will go away. Y square from both sides will go away. So what will be left behind? 14x minus 2y. 14x minus 2y plus 49 plus 150. 49 plus 150, isn't it? Equal to, this side what will remain? Minus 6x minus 10y, then plus 25, 9, 34. All right. So 14x minus 2y plus 50, that is equal to that side. X square is gone. So minus 6x minus 10y, then plus 34. Okay. Now equal to, so now this, so we got the relation, we got the equation. Now only thing is simplifying. So 14x minus, this will come this side, 20x. 14x plus 6x, 20x. Then minus 2y, this will come that side, plus 10y, that is plus 8y. That is equal to, equal to 50 minus, so 25. So this is 49, 150, 25 plus 9, 34. So 50 minus 34, that will be minus 8x minus 8y. 14 minus 1 minute, something wrong. 14 minus plus 6x. X plus 1, x minus 1, x minus 3, x minus 7, y minus 1. X square plus 49, x square plus 49 minus, oh, 1 minute. This should be minus, sorry, this should be minus 14x. Yes, it's minus 14x. Minus 14x plus y square plus 1 minus 2y, and x square plus 9 minus 6x plus y square plus 25 minus 1. Okay. So this will be minus 14x. So minus 14x minus plus 6, that is, yes. So this is what? Sorry, this is, it will be minus 8x. Minus 8x. Okay. So minus 8x, then plus 8y. Yes, this will come this side, plus 8y, then plus this will come this side, so it will be plus 16, plus 50 go this side, plus 16 equal to 0. Yes. So that means if we change the sign, what do you get? Now you can divide by 8. If you divide by 8, what do you get? Minus 2x plus y plus 2 equal to 0. We are dividing each term by, we're dividing the whole equation by 2. Now just use the rule of equation. Okay. So then what do you get? I am writing here, that is equal, it gives what? So now we change the sign, 2x plus, if you divide by 8, you get only x. If you divide by 8, only x. Yes, so minus x plus y, that if we change the sign, x minus y minus 2 equal to 0. So that is the answer. X minus y minus 2 equal to 0. So x minus y minus 2 equal to 0. So P is equidistant from A and B. That means PA equal to PB. We found PA, we found PB. So we equate them. PA equal to PB. So PA equal to PB. So then just question of simplifying. After simplifying, we come to this. So this is the answer. So we have got a relation between x and y. That means we have got an equation containing x and y. Right? Okay. So today we'll stop. So I showed you some application of the first formula, distance formula. There is another formula, but there are some more important questions, important examples where this distance formula can be used. So that we'll discuss in the fourth video. So tomorrow I'll do the fourth video. Okay. All right, then we stop today. Thank you.